Hello and welcome back, dear students, to Chemistry Unlocked classes. So let's resume from where we left in the last class. We were discussing the activities. Today we'll be discussing activities 1.9 and further. Now, children, let's recall the what we discussed in the last class. So, states of matter, we saw that there are three states of matter: solids, liquids, and gases. And we went deep dived into the particles, and we saw that for solids, the particles are compactly packed. For liquids, the particles have freedom to move around, and for gases, the particles move randomly from one place to another. So if I were to draw the boxes, this is how the solids, liquids, and gases look. Okay. Now in these activities, what we are going to do is that we are going to connect this particulate arrangement to their properties. So activity 1.9, let's see what it tells us about the solids. So here what we are doing in this activity, children, is that we are collecting few articles which are all solids, like a pen, a book, a needle, and a piece of wooden stick. Then we'll be doing some experiments and we'll be making some observations. Now, what are the experiments? Sketch the shape of the above articles in your notebook by moving a pencil around them. So suppose this is your book. So you take a pencil and move it around the book. So you'll get a periphery or the space which the book occupies. Do this for all the articles. Okay. Now, do all these have a definite shape, distinct boundaries, and a fixed volume? So let's write yes. What happens if they are hammered, pulled, or dropped? So they will change their shape, size, or they may break also if they are hammered very strongly. Are these capable of diffusing into each other? So no. Diffusing means intermixing. So if I keep a wooden plank on the, say this is my wood and that is the book. So will the wood particles go into the book particles? So no. So the answer is no. Try compressing them by applying force. Are you able to compress them? So the answer is no. So these were some of the experiments we made with the solids. Now let's see what are we deriving or what are we concluding about the solids. So all the above are the examples of solids. We can observe that they have a definite shape, distinct boundaries, and fixed volumes. So in your book, please underline definite shape. So who has a definite shape? Solids. Distinct boundaries and fixed volume. So this is what we have noticed, and negligible compressibility. About the solids, again connected to the particles. So the particles are compactly packed, hence these properties. Okay. Solids have a tendency to maintain their shape when subjected to outside force. So this was this activity. Now let's see what else what other modification has been done. Now what they have done is that they have, what about a rubber band? So they have taken different types of salts, like they have taken a rubber band, sugar, salt, and a sponge. Now all these are solids, but they have different properties. Like rubber band can be stretched and it can change its shape. Similarly, change its shape. Similarly, it appears that sugar and salt, they take the shape of the container. Shape of the container. So the question is asked that are they solids? Are they still solids? And sponge is very easily compressible. So although they are solids, but then they have not they don't comply to the properties of solids which we just now observed. So all of these are solids. A rubber band can change its shape under the force and regains the same shape. So rubber band, although it takes the shapes, it changes the shape, but then it regains the shape. So it is a solid with some elasticity. Then the shape of the individual sugar or salt crystal. So if this is your salt crystal, so the crystal in itself does not change its shape. So if you are, say, putting it in a jar, so it appears that it is taking the shape of the jar. But if you see the crystals separately, so the crystals are maintaining their shape, although they take the shape of the jar like this. So again, it complies to the properties of solids, that solids have a fixed shape and fixed volume. And a sponge is minute holes in which the air is trapped. That is why it is easily compressible. So I hope these activities for solids are clear. Now activity 1.10 similarly talks about the properties of liquids. Now what experiment they have done over here, that they have taken some liquids like water, cooking oil, milk, juice, etc., and they have tried to, or if we try to put them in different containers. So if we take 50 ml of each liquid, and suppose we have a conical flask, then if we have a evaporating dish, and if we have a beaker. Now if you pour in 50 ml of liquid or water in them, so it will take the shape of the container, right? Like this, like this. But the volume for the liquid in all the cases will still be 50 ml. So then what do we derive about the liquids is that it has a fixed, liquids have a fixed volume, but they do not have a fixed shape. Again, connected to the particles. So the particles, they have freedom to move around. So that is why they take the shape of the container, and they because the particles cannot leave the container, so the volume is fixed. So this was about as far as activity 1.10 is concerned. And here there is a slight discussion about the diffusion also. So from the activities 1.4 and 1.5, we see that liquids can diffuse into liquids, and solids also can diffuse into liquids. So let me show you some diffusion over here. So here you can see that liquids, if you drop ink in water, so it easily diffuses. So this is the diffusion of uh, solids into liquids. And let me type here diffusion of liquids into liquids. Let's see what does it show. So here you can again see this is ink plus water, so liquid into liquid, and this one is solid into liquid. That is some particles of KMnO4. If you put in water, again it will diffuse. So the diffusion in liquid of liquid and solid liquid is very easily done, but solid the diffusion does not take place. So this is the takeaway from these activities till now. Now let us go to now because of these diffusions, gases also, because they are able to diffuse in water. So living creatures and aquatic plants, they depend upon the dissolved oxygen and dissolved carbon dioxide. Then we come to the gaseous state, activity 1.1.1. What does it say? Let's take three syringes and close their nozzles by the rubber with the help of a rubber cork. So this is the syringe. Here, this is the rubber cork. So we close it over here. Then in the three syringes, we take solids, liquids, and gases. So one syringe is say, filled with air, other is filled with, let's say, water, and the third one is filled with chalk particles. Now, if you try to push the piston, so who will be easily pushed? So the piston which has of the cylinder which has air will be very easily compressible or can be pushed very easily, whereas the water will show some resistance and chalk will not move at all. So what does this prove? That the compressibility of solids is minimum and the compressibility of gases is maximum. Now, where is this applied in our real life? So, you must have seen LPG and CNG cylinders. So, children, in the LPG cylinder, approximately 28 liters of liquefied petroleum gas is compressed and filled. Just imagine in such a small cylinder, you have 28 liters. That too, when 20% of the cylinder is kept empty. Why? Because to prevent accidents and all. So you know that gases expand when they are heated. So your LPG cylinder, if it is kept under, say, under a sun, so it has this 20% of room where the gases can expand without causing an explosion. So this is about as far as the compressibility is concerned. Then this paragraph talks about the diffusion of gases. So smell of a hot cooked food reaches us in seconds. So that is because of the diffusion of the gas particles or the smell along with the air particles. So more the temperature, more easily the gas particles will diffuse. So this is about the diffusion of gases. Okay. Uh, these images show us the small portion of solids, liquids, and gases. So again, you can see that solids are compactly packed, liquids have freedom to move around in the container, and gases have maximum freedom and they can move and they can leave the container as well. Now, let's go to these questions. So let's solve these questions and I'll go on explaining you along with the solution. So first question is this is the formula of density. Density, let's write over here, D is equal to mass upon volume. So now you have to, what do you have to do? You have to arrange the following items in the order of increasing density. Now let's sort them out. So air and exhaust, the exhaust from chimneys, these are gases. So now why gases have minimum density? Because the volume of the gases is too high and the mass of the gas particles is very low. So if the denominator is more and the numerator is less, obviously the density will be low. Now we have to compare air with the exhaust from chimneys. So you know that the volume of the air is vast. So the volume of air is maximum as compared to the exhaust from chimneys. So how do we, who will have the minimum density? Let us write air. So first air, then exhaust from the chimneys. These are the two gases. Okay. Now let's see who are the two liquids. So the two liquids are honey and water. Honey we know has more mass as compared to water because it is more dense, heavy liquid. But let's see cotton over here. So if you put cotton in water, what will happen is that cotton will float because again, although cotton is solid, but it traps too much of air in it. So then comes cotton. After cotton, the mass by volume ratio of water would be in the series. Then honey, because the mass of honey is more, so the numerator becomes more. So the density becomes density also increases because density is directly proportional to mass. And then we have two solids, which is chalk and iron. So obviously we'll have chalk, and then lastly we'll have iron. So this is the increasing order of these substances which are given as far as their densities are concerned. Question 2, tabulate the differences in the characteristics of states of matter. Comment upon the following. So compare the rigidity of solids, liquids and gases. Similarly, compressibility, fluidity, filling a gas container, shape, kinetic energy and density. So we have covered it in great detail. So I hope you will be able to compare these. Next, question number 3. Now for question number 3, I'll go on writing the keywords. So give reasons. What reasons we have to give? A gas fills completely the vessel in which it is kept. Now here the keyword will be because they have large intermolecular spaces and least intermolecular forces. So that is why, because of this, they completely fill the vessel in which they are kept. A gas exerts pressure on the walls of the container. So why? Because the particles of the gases hit the walls of the container, creating a pressure. Hit the walls of hit the walls of the container. A wooden table should be called as a solid because it has a definite shape and volume. Shape and volume. So it will be called as a solid. We can easily move our hand in air, but to do the same through a solid, we need a karate expert. So why we can easily move our hand in air? Because it has large intermolecular spaces, and wood has least intermolecular spaces and large intermolecular attractions. Attractions. The liquids generally have lower density as compared to solids, but obvious because liquids have a lower mass as compared to solids. So what was the formula? Density is equal to mass per unit volume. So even if you have two similar volumes of liquids and solids, still because the mass of the liquid is less, so the density will be lower. But you must have observed that ice floats on water. Very good point. So if you have, let's say, water in this container, so let's fill it with water. And if you float, if you put an ice crystal, I'm taking the ice crystal with pink color. So if you put an ice crystal, you'll see that the ice crystal floats on water. So why, although ice is a solid and water is a liquid, then why is it so that the density of solid or the ice crystal floats on the water, on the surface of the water? So children, here please remember there's something called as anomalous expansion of water. Anomalous expansion of water. Now, what happens in this case is that when you go on cooling water up to 4 degrees centigrade, the density will go on increasing. And here the density is maximum at 4 degrees Celsius. When you go below 4 degrees Celsius, now the density goes on decreasing. Why is it so? Because when water has to arrange itself in the form of an ice crystal, so what happens is the water molecules, they have to go far from each other in order to form the crystal. So the distance increases so that they are able to form a crystal, whatever ice crystal they are forming. So that is why what happens is that below 4 degrees centigrade, what happens is now the density of the ice is less or decreases as compared to water. And that is why it floats on water. So that's it, children, for today. We'll stop over here. In the next class, we'll complete the chapter and maybe we'll discuss the textbook exercises also. I hope you are gaining or you are benefiting from these classes. Do let me know if any extra or any other help you want, and how do you want my teaching to be modified. Please let me know. I am waiting for your responses. See you again. Goodbye, children.